Thank you. It's so good to see so many of you here still today. I hear some beers being opened. It makes me happy. It helps with my homesickness. As you know, the Lego group lives in Denmark, and so do I. This talk is basically a victory lap for our Kubernetes implementation at the Lego group. Originally, we did this, me and a colleague, Thomas. Thomas, unfortunately, has some trouble with his back. He also has some trouble with being employed at another company. So, yeah, not really that much to do about that. We have tried, but yes, that's just how it is. So, you might notice that there are some things that might have changed a little bit, but we will try. I will try to hurry up. We have a couple of slides to get through. But yes, let's go. As was just mentioned, my name is Paul. I call myself a YAML engineer. I absolutely love YAML. I try and put it in everything that I do, almost. It's not too easy with Choir, even though I try. So I'm a big nerd, and I like Kubernetes and love to play with Lego. I think that we found out in our team that we have a combined amount of 600 sets on display at home in each of our homes. It's largely contributed by our boss, but he also gets paid the most, I think. I'm a Bern admirer, I have to say. It's a very nice city here. I'm a Golang enthusiast, and I absolutely hate meetings, which is also something that maybe come into play here. You might ask yourself, does the Lego group even have an IT department? And I'm here to answer that question. Yes, we do. Talk done. We have about 237 product teams that build IT products. And those vary from cloud services to games to the Lego online shop to products that specifically target manufacturing or all kinds of other different parts of the organization. It consists of around 2,000 colleagues, probably more or less at any given day. And we have an undefined amount of Kubernetes clusters. But it's definitely more than 50. And we'll also get into that a little bit, I hope, if I can remember all of my talking points. So let's get into it. How do you avoid 50 mediocre Kubernetes implementations? We just saw that we have at least more than 50 Kubernetes clusters. So how do we make sure that not all of them are different? Well, the answer is quite simple, I think. You just make one, and then you force everybody to use it. I think that's a way that you could go. But when we thought about that, somebody mentioned XKCD. And we had to address this issue. We didn't want to make just another standard and then have people compete. So this is really the core of the problem, is that we wanted to make something that people wanted to use, so that we don't just have a sprawl of endless possibilities. So this is sort of where we started. At the Lego group, we have a bunch of engineers. As you know, engineers absolutely love Kubernetes. And of course, people wanted to start to use that to run their applications at the factory edge and to run it in the cloud and wherever. So some very passionate engineers started working on running Kubernetes for multiple. Yes, I'm a fan of MS Paint, as some of you might have noticed. I like it. I'm still an associate PowerPoint engineer, but it's I try and be creative with it. Anyways, we had a bunch of engineers who wanted to use Kubernetes, so they started to build a platform. You might think, well, then you have a good governance model, you have nice clusters that all look the same, gets upgraded in time and stuff. No, we didn't have that. Once a cluster was provisioned, it was handed over to the team, and the team would own that cluster and then never upgrade it. And what happened with that was that, well, you had a platform, but that platform had 50 iterations or more. Again, it's undefined. And that was a bit of a problem because nobody really knew how it worked. And we also had the problem that all of our teams were sort of in charge of it themselves. We were very much in the DevOps days at the time, where we had the mindset of you build it and you run it. So people had very different needs. They ran their own clusters with, some used Flux CD, some used Argo CD, some used Vault, some used AWS Secret Manager, whatever. And that was a bit of a problem because we were in the process of also closing down our data center. So we had a bit of a strategic problem where how do we migrate all of these clusters to factory edge or into the cloud when nobody really know how they work? Also, how do we even upgrade clusters since they will start to become vulnerable? So we just decided we're not going to touch it. We're just going to build something new. And that's where we created the vision, Novus. Some of you might be familiar with Latin. Novus means new. I can't argue that we're good at names, but it is what it is. Now it's called new, and we have it. I'm already looking forward to Novus 2. But that's how it is. So we created this vision, Novus, a real platform-engineered Kubernetes service managed that would be a seamless experience, whether you were at factory edge or in the cloud. We would manage all of these things for you that you usually put into a cluster, like GitOps operators and certificates and ingress. We even have K8s now. We have all of the cool operators that you like. But with that, we also wanted to enforce some rules so that we could keep continuing to provide this thing. So we wanted to enforce GitOps. We made the very controversial decisions in the beginning to give no kubectl access. Spoiler alert, I was a user, and I was so mad about having no kubectl access that I switched teams. So that I had it. And we also have some very strict Kyverno policies. So we set out to build this. And we built it actually quite quickly. After discussing it for about a year, we built it in a couple of months. And then, and then we had this new standard. So we had this new perfect platform that we really liked, and we had no users, but the platform was really nice, and we liked looking at it. So we started to think about, well, maybe if we want to continue working here, we should try and get some users. So that's where we get to the maiden voyage, because again, we had this problem of users with burning clusters, an on-premise data center that was about to close down, and people screaming for help with their existing clusters. So what we did was we did 3 things that I can think of. We established a migration task force, which was basically consisting of some consultants, some people from within the platform team, even some users, and we started to just work intensively on migrating people from the old platforms to the new platforms. So actually, I just want to go back a little bit. No, not that far back. One thing that we got out of this with the existing platforms was that there were a lot of users that already had all of their YAML and all of their Helm charts and all that jazz set up and ready to go. They each had their own delivery pipeline, and some people were using some very interesting ways to deploy to Kubernetes. And we had to try and work around that because we were under pretty strict time pressure. Basically, we had, I think it was 3 months to migrate 7 teams or something like that, with a lot of products. And I've tried to categorize them into 3 different ways that we handled them. The first one, where we tried to just directly import them into into our new platform and say, we're just going to adapt whatever output you have from your pipelines and drop that into our new platform and see how that works. It did work, although it did require quite a bit of work to try and understand their existing pipelines. The next type of user that we had was I like to call them lift and shift. I don't really know what lift and shift means at this point, and at this point I'm too afraid to ask. But what we did was we went in there and we said, we think that you should do it in a different way, and then we helped them re-architect the entire thing to be more GitOps native, so to speak, and to build all of the security implementations that we wanted them to have into their products immediately. The last group of users were some very special users that did not have a lot of capacity and also had some very weird use cases. Something like having to run on specific nodes and clusters and having to sit very close to specific machines in the factories and things like that. These different users, they gave us some different problems. The first set of users were okay. We have had a bunch of work afterwards with them. Basically, the stuff that we did for the second part of the users, we had to do on the back end with those guys. And it actually caused more work that we delayed it because we had to keep everything running while it happened. The last set of users have given us the most headache. We still struggle with them. But at least we have a very good relationship with them. We talk to them quite a bit. And the second part of the users, are probably our biggest proponents. They really love us, and they try and convince all of the other product teams within the Lego group to try and move. And what we learned from this is that when people ask for feedback or for suggestions, you have to give them very clear suggestions and not say, well, we could do this, or offer alternatives to what could happen and maybe we could work around it here. Give very clear and concise recommendations because they will thank you for it later. Sometimes it's not possible, we learned that, but at least try to. The next thing that we did was we wanted to keep our users, and we wanted to keep our users happy. And with that, we wanted to try and adopt a sales mindset. And the reason that we talk about sales is because, actually, I have to go back again. We have this thing, autonomous teams. It's really annoying. Basically, it means that all of the product teams can choose however they want to run, and that means they can choose not to use our platform. Which is annoying again, because we really have this perfect platform that we want to force everybody to use. But again, they're autonomous. It's actually quite deeply embedded into our DNA as an organization. And it has forced us to adopt this sales mindset. Actually, one of our bosses, when he hired members for the team, he would, when you got hired, say, "Welcome to sales," because he already knew that this is part of what we were going to do. The thing that we found out is that a lot of our users really didn't care too much about the technical details of our platform, but they really cared about how we communicate with them and how they can contact us and all that sort of stuff. So we did some different things. We made workshops, events where people can join and try and deploy something to our platform, where they can try new features and things like that. These are both on-site, where you go through a guided workshop, and workshops where people can do them themselves. They're essentially the same. We just started with the ones where we sit right next to them and help them out. And now we'll have a 5-minute, no. I think we can get through it. I know that you all want to go and have a party, but, and I want to do that too, but I have, no, we'll finish when we finish. The other thing that we did was we went to events. This is very similar to what we do right now, except we have internal events within the Lego group. We have stuff like, it's called DevCon, where people actually show up, and we have internal conferences. We sometimes even invite outside vendors to help us with stuff. It's a lot of fun. It's very much like this. And we present with technical demos, and we sit at booths and help new people that come in and say, my Lambda bill is so high, how do I switch to something else? And we tell them, well, I have good news for you. The third thing that we really tried to focus on was connecting with our users. So establishing a personal connection with the people that use the platform has proven so valuable for us. The reason is we want our users to always try and ask us when they have a problem. When they have a problem, they should come to us because a lot of the time we know a way to solve that problem. I actually talked to Clément yesterday about this. We talked about we get some service requests from users in a service channel. And we know something is wrong when we have a high churn of service tickets. And we also know that something is wrong when we don't have any service tickets. This is quite similar to how kids work. When they're very loud, something might be wrong. And when they're completely quiet, parents know that something might also be wrong. The next thing that we did, or the next 3 things that we did, we set up a support rotation. We have 2 engineers always dedicated to supporting our users. So basically, our goal is that when you're on the support rotation, you can just drink coffee and then handle the occasional support ticket. But then you switch places every 2 weeks. The other thing that we did was rent an engineer, which is technically an interest-free loan. You can come to us and ask, can I have just a platform engineer to sit in my team and help me with Kubernetes for a week or 2? And we'll say, yes. Let me ask my lead engineer first, but yes. And again, that helps us with understanding each of our users. The last thing that we did was pairing up. You might think that all of this stuff that we do, it generates a lot of communication and meeting with users. And that's why we have done this pairing. What we do is we have almost no meetings within the platform team. We just work in pairs. And then when we want to make a decision, we don't include the rest of the team. We just make the decision to, let's say, switch the entire foundation of the infrastructure to Talos or whatever. And then on Monday, we will say that, well, I decided this. And then somebody might say, please write an ADR. That happens, although not as often as you might think. So it really frees up time for all of the platform engineers. We have almost no meetings in the calendar, which I absolutely love, as you might remember. I hate those. Anyways, this is what we did. And what we really gained from this is by doing all of these things, we stayed in contact with our users so much that we learned to identify when they were having a problem with our platform before people just started writing their own things. Actually, I was thinking about one thing that a user was doing at one point was they were tired of this no kubectl access. So they started to build operations into their own application so that they could call an endpoint, and that would kill the pod inside a cluster. We saw that because we had a good connection with them. And we thought, okay, maybe it's time to give them this kubectl access. And we did that. The key takeaways from these approaches to platform engineering is that you need to sell your platform. You need to, in order to stay competitive with everything else there is. Otherwise, your platform will rust. It will sit somewhere, and people will start to speak bad about it. And you have no chance to identify when there is a problem. The second thing is that you need to keep your users close, because investing in support decreases the need for it. When you support users early in their problem, you can help them fix their problem before it even becomes a problem. Yes. And that is all I had for you today. So thank you.
Thank you very much, Paul, for your insightful talk. Are there questions for Paul?
Thank you. Two questions. How many people are you running and maintaining this new platform? And did this platform also include some database as a service, Redis, you name it?
That's a good question, because I didn't touch on it. Right now in the platform team, we have about 10 engineers in the container platform team, so to speak. We, of course, depend on another platform beneath us, the Compute Anywhere platform. They run all of the on-premise VMs, which we then provision from them. The stateful services are run by another team. So we say to our users, if you run stateful services, you're on your own. We don't support it. It's okay for you to run something like a cache or something, but the reason that we say we don't support it is because we want to have full disaster recovery by, let's say that a cluster goes completely down or etcd gets corrupted somehow. Then we can recreate everything from GitOps, which is also why we enforce GitOps. When it's stateless, that's not a problem. But when it's stateful, it is a problem. The sister team that we have that runs the stateful applications, they're very good at it, and they take backups, and we're able to restore together when something like this happens. So that's what we tell our users. And when we also, no, yeah, they don't do that in cloud yet. In cloud, we tell our users to use services from cloud providers, such that they still don't have to run databases inside our cluster. Yes.
Any further questions? Tai? Right behind you.
Knowing what you know now, would you do anything differently if you are going to build new V2?
We would probably take the same organizational approach. The biggest success of our platform team has been this service channel. It's what our users constantly tell us, that they love the service channel. They can go in there and ask any question that they want, and we'll even help them even if they're not a user and they just have problems with Kubernetes. If we were to do anything else, we would probably use Talos for our clusters. I think so. Right now on premise, we use OpenShift, and while it has a lot of built-in features that we really like, and it has been stable most of the time, it has also been troublesome from time to time. What we would like is to have something that's identical from cloud to on-premise. You could also do that with OpenShift, but we are very interested in stuff like Talos. So
there's another question over here.
Thanks for the talk. You mentioned you sell it, but then you give the engineers for free. So probably management or something need to pay at the end. How do you convince management that you are worth 10 people, that this free service has really the benefit?
So the service is not free. Of course, infrastructure pays the price at the moment for the clusters. We have been working on showback and chargeback. We do include observability in the platform as well. But we're not quite there yet. The FinOps team is not quite ready for stuff like that. So right now we're just focused on trying to figure out how much does it actually cost you, or does it cost the company to run your application in a cluster. You could say that really at the moment they don't really care, because it's much cheaper than what it was before. What it was before was that every user had their own cluster. Right now, they're in a multi-tenant setup, so a lot of users just have very small workloads that don't require that many resources, and then we don't have the overhead of control plane every time somebody wants to run Hello World. Yeah.
Any further questions? If not, then let's thank Paul again for his talk.